This episode of Scholle Physics is going to cover how to find the equivalent resistance of two series resistors or two or more parallel resistors. The first thing we're going to cover will take us back to looking at a series circuit. If you've got one resistor in a circuit, there you see the flow at the top is 1.5 amperes. If we add a second identical resistor, you see the flow drops to half of that, 0.75 amperes. So by adding a second resistor in series, it slows the flow of charge and in effect increases the resistance. And that's what slows the flow of the charge. So what do you think? If we've got 2 ohms of a resistor and 2 ohms, what would be the total resistance? It would probably be 4 ohms. So let's take a look at that. And with resistors as a symbol, there's a resistor symbol. We're going to add a second one. If we have, say, a battery hooked up to those 2 resistors, we'll give it 10 volts. And let's put 2 ohms here and 2 ohms there. What will be the equivalent resistance of those resistors? So in effect, if we can turn this circuit into a brand new circuit, but replace those 2 resistors with a single value, that is the meaning of equivalent resistance. What are those 2 resistors equivalent to if we turn them into 1? So this equivalent resistor over here would be 2 ohms plus 2 ohms, which would give us 4 ohms. All right. So if we sum that up and put it in more general terms, the equivalent resistance of series resistors is just the sum of those resistor values. Now if we had 3 or 4 or 5 resistors all in series, all in a row, we would just continue adding those resistor values. Okay. Now there's one more thing we could determine here, and that is the current. Like what would be the current? So where do we go for that? We need a tool. Georg Ohm came up with that. This is it. Resistance is not futile. It's voltage divided by current. Okay, so another view of that is V equals IR. I being the current, R the equivalent resistance in the circuit, and this V would be the electromotive force from the battery, or the cells, if whatever you've got there. So if I've got 10 volts plugged into an equivalent resistance of 4 ohms, I'd plug in 10 for V. What is I? That's our unknown, and 4 right there. So do a little algebra, divide both sides by 4. 10 fourths is 5 halves, or 2.5. So I would be 2.5. 2.5 what? The current is in amperes. Okay. So that takes you through just a very simple scenario with series resistors. Here's the circuit. We'll bring it back up here. So if we have 1.5 amperes on the top, got a battery and a resistor up there. Let's take a look at what those values would be. Turn on the values. You can see. Okay, there we go. 15 volts and 10 ohms. You take 15 divided by 10, that gives us the 1.5. Down here on the bottom where we've got 2 resistors hooked up, we've got a total of 20 ohms. All right, so if 15 is our voltage value and 20 is the equivalent resistance, 15 divided by 20 is, if you divide 15 and 20 by 5, you get 3/4, or 7.5 amperes. So there we see that series resistor calculation working there. Okay. So next we're going to switch over to parallel resistors. So what if we have 2 resistors in parallel with each other? All right. Let's take 2 ohms again. I like using the same values. Gives us a nice basic comparison. And again, we're going to hook it up to a 10 volt EMF battery source. All right. So what do we do here? Got 2 plus 2. Well, 2 plus 2, that's easy, 4, right? Now recall though, in a parallel circuit, this one's a little different. So here up top we've got the same series circuit as the second circuit from the previous example, 10 ohms and 10 ohms and 15 on the bottom. We're getting 0.75 amps again. But if we put those same two 10 ohm resistor light bulbs there in parallel, you'll notice the ones on the bottom, they're a lot brighter. That's because there's a higher flow in this circuit. In the series circuit, the flow is very slow. It's chugging along here, 0.75 amperes. If you think about this like a single lane road, all that traffic needs to go down a single lane in a loop, and it's all going to be traveling real slow. Down here, the only resistance are in these two branches. Here's one branch and here's the other branch. Okay, but there's two lanes. There's two lanes on this highway. So the same amount of traffic can move faster overall through the circuit. So the flow is greater. We have there 3 amperes. So in this case, 10 plus 10 does not equal 20. 10 plus 10 is a value less than 10. And now you can't really subtract them either. 10 minus 10 is 0, and we definitely don't have 0 resistance. There's some resistance in this circuit. So how do you go about this? So we're going to use a different tool. Instead of just adding the 2 ohms plus 2 ohms, the way to figure this one out for parallel resistors, all right, you take 1 divided by the equivalent resistance equals 1 divided by R1 plus 1 divided by R2. And of course, if there's a third one in here or a fourth parallel resistor in there, we keep on adding those inverse values. So 1 over plus 1 over R3 plus 1 over R4, however many they are. So I'm just going to do that dot dot dot. All right. So that's the formula we're going to try out here. So off to the side, I'm going to do 1 over the equivalent resistance of those two resistors equals 1 divided by 2 ohms plus 1 divided by 2 ohms. Now I'm going to pause right here just to, as you get into more complicated circuits, there's always a way to tell if you're doing this one right. Count the number of branches. There's 1, 2 different branches. See, electrons can either go in this top branch or they can go in this bottom branch. Now occasionally when we get to more difficult stuff, not really more difficult, but just more involved circuits, we may see a couple of resistors on the top and only one on the bottom. And so you might have a question of how do I add those up? Well, add the number of branches up. There's 1, 2 branches, and that's the number of terms we should have here. We've got one branch of that circuit and this another branch. Okay, so there's 2 branches in that circuit, one term for each branch. All right. So what do we do with that? Well, 1/2 plus 1/2. Well, aren't we going to get out 4 again? Like if you add those two together, you get 1/4, right? No. Remember, we're adding fractions here. So 1/2 plus 1/2 equals 1 whole. So we would get 1/2 plus 1/2 is 2 equals 2 halves. All right. Now this isn't a very difficult one to solve, but here we got 1 divided by the equivalent resistance is equal to 1 over 1 if we simplify that. So the equivalent resistance of 2 ohms and 2 ohms in parallel is 1 ohm. You ever think you get that? 2 plus 2 equals 1? Well, in this case it is. Let's try a slightly more involved one. Actually, let's solve this circuit that I have here. We've got two 10 ohm resistors and 15 volts. Let's see if we can come up with 3 amperes as a solution to that. Okay, so let's take that one, hide that, move up a bit here. So in this case, we've got a 10 and a 10 ohm resistor in parallel, hooked up to 15 volts. All right, so we're going to take 1/10 plus 1/10. That's equal to 1 over the equivalent resistance. And that gives us 2/10. All right, so what do we do here? We've got to solve for this. Now our answer is not 2/10. All right, but what we're going to do is call this the Scholle flip method. Let me write this out. You can either cross multiply and solve for RE, or if you just flip the top and the bottom on each side, what we're look at this like two ratios. If 1 over RE is to 2 over 10, then we flip them. RE over 1 equals 10 over 2. Okay, so the ratios stay the same. So any unknown divided by 1 is that value itself. So RE divided by 1 is RE, and 10 divided by 2 is 5 ohms. So 10 ohms and 10 ohms in parallel equate to 5 ohms. And now, if we apply Ohm's law, V equals IR, 15 volts equals I times our equivalent resistance of 5 ohms, and that gives 3 amperes. There it is. All right. So as you move ahead, you might get different values for those resistors. You may get 3 parallel resistors. If that's the case, you're going to add 3. Remember, 3 parallel resistors will give you 3 branches. 2 will give you 2. But so the fraction math, warm up on that. Try a few more out. What's a third plus a fourth? Okay, find that common denominator. So I hope this is helpful, and thank you for watching.